Hello everyone, this is Product Manager Randall. Welcome join today's webinar. I would like to introduce, are you ready for the era of PCIe Gen 4? Since the emergence of the IBM PC in 1981, the system bus has been inseparable from the PC. From ISA, VISA, PCI to AGP, various buses were born. During the development of various buses, the voltage and definition of each interface were not standardized, therefore, and are different and incompatible with each other. So, a new standard has attempted to replace this old bus technology, the PCIe. PCIe was officially announced in 2003 and has gone through 17 years of growth and has been fully popularized in PC computers. Common hardware devices of PCIe include independent graphic card, independent audio card, USB 3.1 interface conversion, solid-state hard disk. These buses all belong to PCIe Gen 3. With the official release of AMD's third generation Ryzen CPU and X570 chipset, PCIe Gen 4 bus technology has officially moved from behind the scene to the front lines. And AMD has turned PCIe Gen 4 bus technology into a reality. PCIe Gen 4 is the next generation of high-speed interface. Since it is not common in technology, many people have begun to discuss it. The data transfer rate of PCIe Gen 4 is twice of PCIe Gen 3. The two standards are very similar in structure. Their coding method remains the same, but the frequency has doubled. PCIe Gen 3 offers a data transfer rate of 8 GB per second, which is the rate of its transfer per second that gets transmitted from the host to the end device or endpoint. PCIe Gen 4 doubled from 8 GB transfer to 16 GB transfer per second. The by 16 bandwidth reaches 31.5 GB per second, and the two-way approaches 64 GB per second. This means that PCIe Gen 4 has a channel speed that is even higher than the average CPU or memory bandwidth. The common NVMe SSD in the industry used for PCIe lanes. So the expanded rate of PCIe Gen 3 is 4 lanes times 8 equal to 32 GB transfer per second, while PCIe Gen 4 are giga transfer per second per lane speed. 4 lane times 16 equal to 64 GB transfer per second. The increase in bandwidth allows faster data transfer for PCIe to endpoints such as SSD or GPU. Using the PCIe Gen 4 controller included in the new AMD X570 chipset can double the bandwidth and be closer to the expand value of 64 GB transfer per second. Tech PowerUp did a special test using RX 5700XT graphics card with Ryzen 3900X processor, SRock X570 motherboard, and let the graphics card run on using PCIe Gen 4 by 16, PCIe Gen 3 by 16, and PCIe under Gen 2 by 16 modes. testing up to 21 games. It didn't matter whether the resolution was set at Full HD, 2K, or 4K. The performance of playing games in PCIe Gen 2, Gen 3, Gen 4 by 16 modes was almost identical, with a difference of only 2% at most. This is actually expanded. Over the years, continuous tests have proved that the impact of PCIe bandwidth on game performance is not oversized. Even a base PCIe Gen 3 by 4 is sufficient. Of course, the emergence of PCIe Gen 4 itself is not just to improve the performance of gaming, but it is aimed at other occasions where higher bandwidth is needed, such as high-speed SSD. In the past, it was said that the hard disk was the biggest bottleneck of the PC. Indeed, in the era of HDD or SATA SSD, the AHCI protocol is supported, and the very slow SATA channel with a speed of only 600 megabytes per second leads to hard disk read and write speed that lag behind the CPU and memory. When the three are working together, the hard disk overlaps, making the whole machine inefficient. Now, M.2 NVMe SSD can use the PCIe Gen 4 channel and increase the read and write speed to about 4,000 to 5,000 megabytes per second, which is nearly 10 times higher than the previous make-sure read and write speed of SATA SSD, and about 30 to 40% higher than PCIe Gen 3 SSD. The speed of the hard drive is finally really catching up. Like PCIe Gen 3, PCIe Gen 4 is forward and backward compatible. This means that PCIe Gen 4 can detectably replace PCIe Gen 3. But it almost means that if a PCIe Gen 3 card is connected to the PCIe Gen 4 slot, the card will comply with the PCIe Gen 3 specification and only need to use 8 PCIe Gen 4 lanes. In other words, in addition to the higher bandwidth outlined above, PCIe Gen 4 also allows designers and system integrators to increase the number of expansion cards of the platform. The GPU card is connected to the PCIe Gen 4 slot, which can transfer the data being loaded in the GPU memory faster and reduce the delay on the PCIe bus. As the file size and graphic compatibility of video games continue to increase, and machine learning applications continue to require larger and larger data set. So PCIe Gen 4 will play an important role in increasing the frame rate and reducing the computing time. Similar to PCIe Gen 4 GPU, connecting PCIe Gen 4 NVMe SSD will result in higher data transfer rate and lower latency. It is still forward or backward compatible. So you can connect any SSD gen to the PCIe Gen 4 interface, and the speed will depend on the controller generation of the PCIe SSD. AMD is the first to push the new Ryzen CPU and X570 motherboard, and their PCIe Gen 4 has caused a lot of discussion. Intel Ice Lake SP, Tiger Lake Up3, and 11th generation Rocket Lake will also support PCIe Gen 4. With the demand of future platforms, SSD manufacturers have launched PCIe Gen 4 NVMe SSD one after another, which will surely become a trend. On the contrary, the effectiveness of PCIe Gen 4 at the correct state in the graphics card area has only been increased by 2%. Whether there is a need to upgrade will be a matter of opinion. Thanks for your time, and any feedback is welcome. Please give us your feedback via scanning the QR code and complete the survey. You will have a chance to win one of an iTunes Apple card. That's the end of webinar.